Well, hello everyone. Welcome to the 2021 NSS Convention Virtual Edition. My name is Bill G. I'm going to be doing a presentation today regarding cave light comparisons. I will take a group of caving lights and run comparisons on them as regards to their output and to the runtime that they have on various different kinds of batteries. I don't have a wide selection of lights to run from. One of the really important things in this presentation is how I collected the data using a Raspberry Pi and a light sensor and some simple Python programming. So most of this presentation is going to be just running through a slide deck with voiceover. I thought I would tape an introduction here just to show myself, but with that, let's get into the slideshow. The cave light comparison is going to run through 5 different lights. The object of this is to find out how much light they produce, how long do they run on a set of batteries, and how do different batteries change the runtime. All of those have an effect on which light is most useful in a cave. Obviously you want a bright light, you want a light that runs for a long time, and you want to know what kind of batteries will give you the longest runtime when you're in the cave. I used 5 different lights for this testing. The first light is a Princeton Tec Apex, which is about $85 or so on Amazon. My local grotto, Kansas City area grotto, owns a whole bunch of these that we use as loaner devices for amateur caving and introduction to caving and so on and so forth. I used one of those lights. They are a somewhat older version of the Princeton Tec Apex. Princeton Tec has done a bunch of different versions of the Apex light with different light outputs depending on which model you get. Ours are probably 2 or 3 years old. They are not the very latest version of the Apex. Still, it's an interesting comparison. I also used a Stenlight S7, which is by far the most expensive light in this comparison. For the price of one Stenlight, you can buy 2 of everything else at least, and probably have some change left over. One of our members has a Wowtec AS25. These are about $30 on Amazon, including a battery, a knockoff of the Phoenix and Zebra lights. And then another of our grotto members had a couple of unbranded lights, which he bought for really cheap, as you can see by the pricing here. Really cheap on eBay. And then, as you will see, there's a reason why they were really cheap. The Princeton Tec Apex is very popular among cavers, one of the most popular lights out there. It runs on 4 AA dry cell or rechargeable batteries. 166 grams without the batteries. That's medium as far as the weight goes. It's not the lightest or the heaviest of the lights I tested. It's reasonably sturdy and waterproof. The lifetime replacement warranty is really nice, and as a grotto we have taken advantage of that. The 14 lights that we bought have probably turned into 20 different lights because of replacements that we've had to get. It does have a choice of either a spotlight or a side light. Unfortunately, cannot run both at the same time. You get one or the other. And each of those has multiple levels of brightness. There is a warning flash when the batteries get low, and it will not run the batteries down to 0. So here's a picture. This is a stock picture of the Princeton Tec Apex. It comes in various colors, and it's a reasonably small light, and the battery pack is somewhat larger because it's 4 AA's, but it's like I said, a very common light, very popular light among cavers. It has a fairly good mix of reasonably low price and reasonably good quality and reasonably high output and reasonably long battery life. The Stenlight S7 is also very popular among cavers. This is a light that was designed from the get-go to be a caving light. It is the highest price by far, as I mentioned. At 124 grams, it's one of the lighter lights that I used. Small, lightweight, very sturdy, and very waterproof with 4 brightness settings. It has by far the longest battery life of all the lights I tested. And this one is important. The light output is nearly constant across battery life. You'll see that when we get to the graphs. The graphs for the Stenlight are nearly flat until they hit the end, and then it falls off a cliff. The graphs for all the other lights trend downwards almost from the get-go. They are at the original brightness for only a few minutes, and then they start dimming down. The Stenlight does require a special charger. However, it will run on practically anything that provides between about 6 and 14 volts DC. So you could run it on a lead acid battery, you could run it on a pack of 4 to 6 or even 8 AA batteries. Even a 9-volt battery will run it, and I did do that test, and it's kind of surprising how long it runs. It's more than I expected. And there's a picture of the Stenlight S7. This also is a stock photo, and it shows both the Stenlight and its special battery. That special battery is two 18650 lithium-ion batteries wired in series. That's an important point. Some of the other lights that I am testing use the 18650s wired in parallel. The Wowtec AS25, it's an A2S, works and looks much like the Zebra and Phoenix light. It uses a single 18650. It is the lightest battery at 56 grams with, it's the lightest light at 56 grams without the battery. Sturdy and waterproof, 3 brightness levels plus a strobe. The beam pattern is wider than the Apex spotlight, but not as wide as the Stenlight. It is fairly usable in a cave, and as I said, one of our members has a couple of these. He puts 2 on his helmet, which is a common way of dealing with the Phoenix and the Zebra lights. And at that price, you can pretty easily afford them. You can see in the bottom of that picture, the $30 includes an 18650 battery, which has a built-in USB charger. So you don't need to have a special external charger for that battery. All you need is a USB power supply of some kind. There's a 2-cell unbranded light that another of our members picked up off of eBay. It's expensive, it's large, it runs on either 1 or 2 18650 batteries. It's 1 or 2 because the batteries are wired in parallel, so you can use either 1 or 2. The light, of course, changes the runtime, but it will not run the batteries down to 0. It turns itself off when they reach a certain point, and you'll see that in the graphs. It's mostly plastic, and it's also quite large. So looking at it here, you can see the comparison. The battery pack is hiding on the back of that strap, and the 2 batteries in front are to scale, and those are 18650 batteries. So yeah, it's big. It does have a very broad beam pattern. It does not have any kind of a spotlight mode, but the pattern is very broad, almost as broad as what you would get out of a carbide light. And then in the same basic vein is a 3-cell unbranded. It's a model W608, but I couldn't ever find a brand on it. This light is also large. It's inexpensive, has a very broad beam pattern, and this one runs on either 1, 2, or 3 18650s. They are again wired in parallel, and it looks like this. This light has an interesting couple of modes where it will strobe on either blue or red. I don't know why they chose to do that, but they did. So in addition to its white outputs, you can get a strobe in either blue or red. I use several different kinds of batteries for doing this testing. The first is 18650 lithium-ion Garbarial brand. They are rated at 5,000 milliamp hours, but the actual capacity is only about 1,000 milliamp hours. See my other presentation regarding battery comparison for more details on that. I also used a lithium-ion so-called purple battery. This is an unbranded battery that I got from the 18650batterystore.com, and its rated capacity is 3350 milliamp hours, and it actually does produce about that much. I also used the Stenlight battery pack, which is a 2400 milliamp hours, but at 7.2 volts. Remember, those 2 batteries are wired in series. I also used some nickel metal hydride Eneloop AA batteries at 2000 milliamp hours, and some alkaline AA dry cells, just to see what the dry cells really do. The advantage to the AA batteries is that you can buy them in almost any store. If you need some batteries on your way to the cave, you can stop in at the convenience store when you're getting gas and you can get some batteries. Otherwise, there's not a lot to recommend a AA battery. They produce less power and less energy than any of the 18650s. Even the cheap Chinese knockoff 18650s can produce more energy than an alkaline battery. To measure the brightness and runtime, I used an old Raspberry Pi Model B. This is the original Raspberry Pi. It is not one of the newer Pi 2, Pi 3, Pi 4. It is the original Model B Raspberry Pi. I hooked up a TSL2561 light sensor to the I2C bus, and I placed the sensor and the light inside an old picnic cooler, a 48-quart plastic picnic cooler. It's been pretty well junked out and not much good for use as a cooler anymore, but it works well for this. And I wrote a simple Python program for the Raspberry Pi which will record the brightness at regular intervals. The program allows you to set the interval that you are recording. It also lets you set a cutoff point when the light gets below some level. It closes off the data file and shuts itself down. As an arbitrary choice, I chose a cutoff of 20 lux to end the testing. So all of these lights I tested down to either getting to 20 lux or shutting themselves off. In some of the lights they shut off before they got down to 20 lux. So what is a lux? We'll take a little bit of a side path here and talk about how you measure the brightness of a light. All of my data shows the brightness in lux. The lux is the native measurement that comes off of the light sensor. It is a point measurement of light intensity, similar to voltage. Or you might also, if you're looking at a garden hose analogy, this would be similar to the water pressure that's in a garden hose. It doesn't tell you much about how much water comes out of the hose, but it sure tells you what the pressure is for the water that's in the hose. A lux that is not exactly the same as a lumen, and they're not directly comparable. The well-known unit of measurement, the lumen, is 1 square meter illuminated at 1 lux of intensity. Well, these lights don't have an even pattern, and for that matter, they don't even have the same pattern. So just because I can measure some number of lux at the center of their beam, which is what I did, that doesn't mean that they have that same amount of light output across the entire beam. It also means that a light which produces a very narrow beam can be very bright in terms of lux and still have a rather low lumen output. On the other hand, a light which has a rather low lux rating can spread that light out over 180 degrees and therefore have a rather high lumens rating, just because there's so many square meters that are being illuminated. There's no direct comparison because of how the light output depends on the beam pattern. There is a Wikipedia article on lux which gives much more detail and has a table giving lux levels for various lighting scenarios. So how many lux is enough? How bright is bright enough? A UCO candle at about 1 foot is about 2 lux. So there's your basic idea, 1 candle power, if you will, although the distance level for candle power is different. But at about 1 foot, a candle lantern makes about 2 lux. It's surprising how much light that is when you're in a cave, because of course, being a candle, it spreads that out over nearly a sphere, and it's pretty even across that entire sphere. 20 lux generally is enough to get you out of the cave in an emergency. 200 lux is a nice light around a cave camp. Again, it depends on the beam pattern. In a cave camp, you'll want something that's a little bit broader. 2,000 to 3,000 lux is useful amount of light, especially with a wide beam pattern. 10,000 lux is the lap of luxury, but be careful when you get them that bright. Oftentimes that is the spotlight mode, and the spotlight mode is not all that useful for real caving. The Apex spotlight beam is an example of that. It's very bright, but it's too narrow for most caving. You can't see your feet, you can't see off to the sides, you have no peripheral vision with it. So looking at the lux output on the high setting for all of the lights I tested, here we see that the Apex spotlight had by far the highest output in terms of lux, but as I just said, it's a very narrow beam. The Apex side light is considerably less output, but a considerably wider beam. The Stenlight and the Wowtec and the 2-cell and 3-cell. The Stenlight on turbo mode I put in here at 12,000 lux. I did not run any graphs on it. The problem is that with the turbo mode, the light gets very hot and will only run for a short time in that mode. And that's especially true when it's inside the picnic cooler that I used for doing the measurements. If it were in a cave, then the turbo mode would probably run for much longer, simply because the cave being cooler is going to cool the light. You're not going to have an accumulation of heat inside a closed container as you did with the testing that I did. The light on the output on medium, as expected, is considerably less. The 2-cell and the 3-cell cheapo lights don't have a medium setting, so they're not listed here. They only have high, low, and strobe modes. And then the output on the low modes, you can see that the Stenlight at 215 lux, that's about what I said was good for around a cave camp. It actually is enough to get you out of a cave. It's not more than enough, but I have caved on the Stenlight on low and got away with it. It's not great, but it works. Most of the time I do my caving with my Stenlight on medium, and that works out very well. So now let's get into the graphs. So the first, I have a whole bunch of graphs to present here, and I'll talk a little bit about the details on these as I go through. The first thing I think to note is that all of these graphs were produced using a program called LabPlot. LabPlot is primarily designed for Linux, but there is a Windows version of it. You could probably do these graphs in a spreadsheet like Excel or LibreOffice or something like that. I did not try that. This light shows this graph shows all 5 lights using the high mode, and in the 2-cell and the 3-cell lights, which are 18650s, I used a purple battery, which is the 3000 milliamp hour version of the 18650. Notice the green line in there. That is the Stenlight, and you'll see this through all of the other graphs. The Stenlight graph is flat as a board up until it hits the end, and then it just drops off the cliff. It's interesting though that even though the Stenlight dropped off the cliff down to a low mode, it continued running for quite a long time. So 998, call it 1,000 minutes. That is something in the range of 13 hours. The rest of the lights, as you can see, started off fairly bright and immediately started going downwards. The next graph is the same 5 lights and the same batteries on medium modes. This time notice that the Stenlight is the brightest of the medium settings, and it runs for the elapsed time in hours. It ran for over 35 hours on medium before it hit the cliff and dropped off. The Apex spotlight was also fairly flat. As you can see, that's the red line there. It was fairly flat until it hit its cliff, and it just shut itself off. It went down very quickly, clear to zero. The purple is the Wowtec light. That also shuts itself off when it reaches a certain limit, and you can see that at around the 18-hour mark. The reason that the 2-cell and 3-cell lights are the graph lines are broader is because the light output from those 2 lights is all over the place. When you look at the data, you see that it goes from 200 lux, and then 2 minutes later it might be 220, and 2 minutes later it might be 210, and 2 minutes later it might be 180, and 2 minutes after that it's back to 210, and then after that it's back to 190. It is all over the place. Those are very poorly regulated lights. The roughness, the variation in those graphs will become more apparent as we get into some of the other graphs. So here is a low mode comparison, again using all 5 lights and using the same purple battery. Notice that the Stenlight, the green light, went out to over 200 hours before it fell off the cliff on its low mode. And in fact, it kept going. The low mode on the Stenlight kept going, let's see, almost 200 hours. That's over a week. It ran for almost 9 days before it was finally down under 20 lux. And that was a long test. You can see that none of the other lights even came close to producing light for that long. When you look at the Stenlight in 3 modes of Stenlight using its battery, this is taking, so on the high mode it ran for about 7 hours, on the medium mode it ran for 35-ish, and on the low mode it ran for a little over 200 hours. Notice how flat those lines are before they hit the cliff and just fall off. I did run the Stenlight on several different kinds of batteries. I used its original lithium battery. I used 6 AA nickel metal hydrides, 6 AA alkalines, and a 9-volt. The 9-volt battery was rather surprising. That's the green line down at the bottom. It is the lowest light output initially, but I was extraordinarily surprised to find that it ran for over 40 hours before it finally started to dim down. And notice how flat that line is. In fact, all of those lines are very flat up until they hit the limit. It is interesting that the alkaline battery and the nickel metal hydride battery lasted almost exactly the same time before they fell off the cliff, but the alkaline battery kept on going longer on the tail end of it, longer than the nickel metal hydrides. When I look at the Princeton Tec Apex light in its spotlight modes, this was using nickel metal hydride rechargeable batteries. You can see that on the spotlight low it had fairly flat output. On the medium it was fairly flat, but it only ran on medium for about 2.5 hours. And so it's on the low setting on the spotlight, it ran for about 12 hours and then shut itself off. It just turned itself completely off. The other modes tailed off to very dim and were really not usable after a couple of hours. So the spotlight mode on the Princeton Tec Apex is something that you only use on rare occasions. It's not your long-term light in a cave. For the sidelight modes, the difference is more apparent. In the sidelight mode, there is no medium setting. There's only a high and low, at least on the lights that I was using. You can see that they both lasted almost 12 hours, about 11.5 hours. But the high hit a cliff and fell off just after 8 hours, whereas the low mode ran all the way out to 12 hours and then the light shut itself off. For the Wowtec light, you can see that the regulation on it is rather poor. It starts off bright and immediately starts falling off the cliff. This light does turn itself off when the battery gets too low, and that is apparent there in the graphs. They go out so far and then just drop down vertical. So at that, it was fairly usable. On the high mode, it ran for about 3.5 to 4 hours. Medium mode, which is quite usable for caving, ran for in the neighborhood of 20 hours, 18 to 20 hours, although it was getting dimmer and dimmer as that went along. And in the low mode, it ran for 66 hours, which is several days. That's almost 3 days. And at a level that would be suitable for use around a cave camp, or if you had a real emergency and had to get out of the cave, that's enough light to get out of a cave. It's not more than enough, but it would do the trick. When we changed the Wowtec over to a purple 18650 battery, this shows that the battery which comes with the Wowtec is actually a pretty good battery. It tested out to somewhere a little over 2,000 milliamp hours, which is not all that bad. The Wowtec, the purple battery, tests out at a little bit over 3,000 milliamp hours, and so provides longer run times, but it wasn't all that much longer, which I thought was a little interesting. So here is the Wowtec using 3 different batteries on the high brightness. You have the purple battery, which is about 3,000 milliamp hours, the Wowtec battery, it's about 2,200, and then an ultrafire battery, which is rated at 5,000 milliamp hours, but actually produces only about 1,000 milliamp hours. You can see that they all start off more or less the same brightness, but they tail off fairly rapidly, especially the ultrafire, the cheapo battery. And this is elapsed time in minutes. So 97 minutes, about an hour and a half on that cheapo battery on the high setting. Much the same story using 3 different batteries on the medium setting of the Wowtec light. The run times are a little bit longer, but actually not all that much considering the difference in the brightness. And then the Wowtec light again on the low brightness setting. You can start to see in this graph some of that variation. The Wowtec light was not as bad as the 2-cell and 3-cell no-name lights, but it still produced various variable output. It would be up and then down and then up and down and then down and then up and then up and then down and then up and then down. It was all over the map, and that shows in how rough the line is here. Those lines are not smooth, straight lines. Moving on to the cheap lights, this is where it becomes readily apparent just how cheap these lights are. I tested them with both a Garbarial battery, which is, like I said, about 1,000 milliamp hours of true capacity, and a purple battery, which is about 3,000 milliamp hours of capacity. So this shows very much the difference in the two batteries, and also the difference in the high mode. Notice that it starts off at reasonably bright and immediately starts trailing down. The graph is all over the place as far as being up and down, but the trend is apparent. On the low mode, it's even more apparent. And notice that some of these were using 1 battery, and some of these lines are using 3 batteries. So obviously the longer lines have 3 batteries. Now those still, for a low mode, it's still not running all that long. It ran for 28 hours in the low mode, and that was down to 20 lux. Its usable output was probably only in the range of 15 to 20 hours before it started getting too dim to be really usable. That was on 1 purple battery, by the way. And then the 3-cell light using a single battery, this really shows off the difference between the purple batteries and the cheap batteries. And the 3-cell light on low with 3 batteries. And now moving to the 2-cell light, this graph is even more apparent as to how the light output goes up and down and up and down. It's very poorly regulated light. This light does shut itself off when the batteries get down to a certain point, and so there is no tail off. It never just quite goes off to as dim as it can get. It reaches a point and somebody hits the switch. So here's the 2-cell light in low mode using either 1 battery or 2 batteries, and either Garbarial, the cheap batteries, or purple, the good batteries. And then the 2-cell light using a single battery. And the last graph I have here, this is the 2-cell light using 2 batteries. The elapsed time and even on low with 2 purple batteries, it only ran for just over a day. And at that, its light output at the end was very dim. So in conclusion, you get what you pay for. The Stenlight, as I've said earlier, is the highest price light by far. You could buy a set of 2 of all 4 lights, of the other lights, for less than what you pay for 1 Stenlight. But on the other hand, the Stenlight has very excellent regulation of its light output, and it has by far the longest life, longest runtime of any of the lights I tested. AA powered lights are convenient, but the 18650s last longer. Again, I refer you to a presentation that I did comparing the batteries and how much energy you can get out of them. Good regulation of the light output costs money. The cheap lights don't regulate. They just kind of go with the flow, as it were. Lumens and lux are both important. As I said, lux is like the pressure. That's like the voltage. coming off the light. The lumens is the amperage, or the power, if you will. It's the amount of water, the gallons per minute that comes out of the hose. Lux is the pounds per square inch in that hose. So both are important. A very narrow, very bright light like the Apex spotlight mode is handy for some things, but it's not useful for just moving through a cave. All of the data that makes up this presentation is available on the website, and I will close off with a link to the website where all of that data is. You can download that data and run it through your own graphing program and see what it is. This presentation, this slide deck, is also available on that same website. So with that, thank you very much for your attention and your time, and I hope this has been very informative.